then topic models. So guys, for topic, let's start with the topic modeling now. Let's try to first understand what is topic modeling, what are the applications of topic modeling, and then how we can achieve the topic modeling in Mahout using CVB, collapsed variational Bayes algorithm. Okay, so I think once we complete this, the only only thing remaining will be the actual metrics which will be used to evaluate the clustering performance. So topic modeling is one of the interesting aspects, and there has been lots of research happening over the topic modeling. There have been so many applications also specific to topic modeling, guys, because one of the key problem statements in over the industry about the topic problem. So ideally, topic modeling is nothing but just identifying the topic on which a specific article is talking about, or say document is talking about, or any other content is talking about. So this could be applied in different ways. For instance, you could have heard about text summarization. So that's a very good application of a very good application, and can save a lot of time for the end users who are reading the specific articles, news articles or content kind of thing. So basically, if you can summarize the data and just present it over to the user, where user can just read through the summary of the content and then can decide whether or not he has to read the entire content based upon the summary of the data. So this can be applied in all these different fields, by the way. So ideally, topic modeling, again, going back, it's just identifying the topic for which it is talking about, for which a given news article or any article is talking about. So here are the suite of algorithms that uncover the hidden thematic structure within the document. Collections provide a simple way to analyze text, unlabeled text. So Latent Dirichlet Allocation is one of the algorithms which is used for doing the topic modeling. However, it can also be used in other aspects also, like doing the face recognition. Also, you can apply the LDA. So anyhow, we are not going to cover face recognition specific algorithms here, but we'll be looking at the topic modeling, guys. And LDA is basically used for face recognition technique, and this is how it will look like. You will have a corpus of face images, and you pre-process the images and create the templates out of it and generate the model using the LDA algorithm. And then once the model is being created by using the LDA, then you use the model for further analyzing the face, new unseen faces. So you use the new face images and do the pre-processing stuff, and after doing the pre-processing, and again you pass it to that model. This is the model actually which was generated in the previous step, and then in the training phase, and then this model can be able to further classify the images into different images and recognize the actual image, guys. So this seems to be pretty much similar to that of the classification kind of problems, but however, this is actually part of this clustering algorithms, CVB algorithm, and so both CVB and LDA pretty much work in the same fashion again. And which of the following statements are true? So guys, let's take some quick questions from Annie and then probably move further to understand the applications of topic modeling in detail. So yeah, all of the above, correct. Which of the following ways can be used to generate the initial K random centers to be used by K-means or fuzzy K-means clustering algorithm? Random seed generator, canopy clustering, or both A and B, or none of the above? It's both A and B, which is both random seed generator and canopy clustering, both, guys. Okay, so guys, let's try to understand LDA, but however, I have to still change the content, but since both of them are same CVB and LDA, so it's worthwhile understanding LDA. The LDA is a generative model like Dirichlet clustering because it's followed probabilistic clustering techniques, LDA and CVB, and you start with a known model and try to explain the data by refining the parameters to fit the model to the data. So here we are not identifying the model first and fitting the data to the model, rather we are actually fitting the model to the data, guys, the other way, similar to that of the probabilistic modeling. And the LDA does this by assuming that the whole corpus has K number of topics. So the way the LDA operates is it basically assumes the entire corpus is actually talking about different K topics, just similar to that of K clusters. and each document is talking about one of these K topics. So it will not identify different topics for each document. Instead, it will identify K topics totally, and it will just try to map that one of these K topics to all the documents. I mean, to each of the documents. Then therefore the document is considered a mixture of topics with different probabilities for each. So that's why it is considered as mixture of topics with different probabilities. So what this does is either CVP or LDA basically say it has identified 10 topics out of 2000 documents. Then all the 2000 documents will be assigned to all the topics in LDA or CVP both. It will assign to all the topics but with different probabilities. So say topic 1 and document 1 could be, probability could be somewhere around say 9. The topic 1 and document 1, sorry, topic 2 and document 1, the probability could be 0.2. So based on this probability, whichever has the highest probability, we can determine that okay, this particular document belongs to the specific topic. It's that way. And fuzzy k-means algorithm and LDA. So let's try to compare initialize K clusters. The algorithm is similar to that of k-means. So this one is similar to that of k-means, fuzzy k-means, and initialize K clusters until converged. So compute the probability of a point belonging to the cluster of every point cluster. Yeah. So fuzzy k-means also similar to that of this overlapping clustering, right? So it basically assigns each point to each cluster. So that's why we are trying to compare fuzzy k-means with LDR CVP. Compute probability of point belong to a cluster of every point. Recompute the cluster centers using above probability membership values of the points of clusters. So Twitter uses Mahout's LDA implementation. Guys, Twitter uses Mahout's LDA implementation for user interest modeling. So to identify the user interest, it uses LDA and maintains a periodically synchronized with Apache trunk for Mahout and GitHub. So this is how you will run CVP algorithm, LDA. So before running LDA, okay, so the first of these number of topics is like the K centroids, the K means you need to figure out number of topics based on the data you have. So based on the data, you have to first figure out how many topics it is talking about, how many topics could be possible within your input data set, and then identify the K value. And then a lower value of the number of topics usually results in broader topics like science, sports, politics. So if you select very less value for K, then your topics will return like science, sports, politics, and it engulfs words spanning multiple subtopics. So if there are any subtopics under science, under sports, under politics, it could not be possible if the K value is very less, very small. A large number of topics results in focused or niche topics like quantum physics and laws of reflection. Then a large number of topics also means that the algorithm needs lengthier passes to estimate the word distribution for all the topics. This can be serious slowdown. So large number also could result in different issues, since it has to do so many iterations, so it will be seriously slowing down the application performance because you are dealing with large volumes of data. And a good rule of thumb is to choose the value that makes sense for the particular use case. So it depends upon the use case which you guys choose, and based on that the amount of type of data you have, based on that you arrive at a K value. And the Mahout's LDA implementation is written in as a map reducer, so it can be run on large Hadoop clusters. Both CVB also, guys. So here are certain parameters which you need to pass into it. This determines the size of matrices, so all these things. So this anyhow we'll cover while running the algorithm itself. So guys, the results can be analyzed through some utility called as vector dumper. So this LDA print topics also is deprecated now. So we'll be using vector dumper to analyze the outputs generated by CVB. So that anyhow will run in a while from now. So finally the results could be like this, guys. So topic 0 might be talking about wheat, agriculture, exports, tons. Topic 1 could be, say, South sand oil production, means this oil and gas. This is agriculture, and this seems to be banking stuff, and this seems to be stock markets, and this seems to be some dummy topic over here. So applications of topic modeling. These are not really, this slide is not really properly organized. I'll show you the actual applications of topic modeling in the next slide. Applications here are visualized as tag clouds and then visualizing topics across time. So these are key applications of topic modeling, and for practical purposes it could be used. This is actually functionally how this topic modeling can be achieved. It's like key value format, key is a pair of integers like that. So guys, that previously we have ran that program, right? So that has actually generated the output also. It says the cluster 0 contains the points, this part. See, since we have used that named vector, it has shown the name also. Otherwise it would have not written this name. So cluster 0 contains this point. So you guys try out with different threshold values for canopy clustering, and this cluster generated would be different if you guys try out with different threshold values, as I mentioned in the program itself. You just replace those values and try it out, okay, and just try to evaluate. And the other difference is here, since we use that named vector, it has got the name of the news article also. Okay guys, so that's pretty much it over here. Okay guys, so let me run this CVB. So guys, don't use this LDA specific commands now. These are not working, however. Start with something else. I'll show you. Okay, so here are the steps for CVB, how to run the CVB algorithm. So guys, this is like 20 news groups data set, 20 news all. So this 20 news groups, you know, this will have 20 different topics. How do you fs-ls 20 news all. So guys, you can see different folders under this 20 news all. This is like theism, computer graphics. These are like different topics over here. Okay. Under each of these folders, say if I take theism, under theism there are news articles with this, like this guys. Hyphen text, if I do hyphen text on this particular news article, it will have some content like this. Okay. So I'll use this 20 news groups data set, however, to run the CVB algorithm so that we get more meaningful topics out of this, guys, out of this 20 news groups. Okay. You guys, however, can apply this over that previously discussed one. I mean, over the writers news articles also. For downloading these 20 news groups articles, I have given the link also. Please feel free to download it from there. Okay, and you have to do some pre-processing also. Those pre-processing steps I have actually listed down in, not in this session, maybe in the next session, in the classification session. I mean, the next session will be purely for classification, and in which we'll be running this Navy base algorithm. So in the Navy base, I'll show you how to pre-process that 20 news groups articles. But for time being, you guys please use that writers news data set only. But since I have already done the pre-processing, so I'll use this data set for doing the topic modeling also. Okay, so it's one and the same. If you use writers news articles also, if you use this data also, it's one and the same. There is no much difference. The only thing is you will get so more meaningful clusters because the data is already been organized in such a way that each news group has its own articles there. Okay, so to run this, what I would do is the first step I'm supposed to do is you know, I'll convert the data into sequence files, guys. Okay, Hadoop fs-ls. So in order to convert the news articles into sequence files, what will you do? You will use that sequence directory command, right? Using the sequence directory command, you can be able to generate the fs-ls, this news to sequence. You can be able to generate the sequence files out of it. Okay, so this is the sequence files. So if you want to understand, okay, what is the sequence files contains, Hadoop fs-text pipe more. So this will contain the group name, article name, and the actual content of the article like this as a key value pair. And however, this is a sequence file. Since I have used text, I am able to print it as a text over there. Okay, you have to but run that sequence directory command, guys. Exactly similar to that of k-means to generate that sequence files out of that news articles. Okay, after you guys generate it, the first step I'm going to do is okay, so I have to generate the writers vectors also. So anyhow, generating vectors also we already know, right? Using the sequence to sparse command. So use that sequence to sparse command to generate the news articles. I mean, write TF IDF vectors also. So since already we have executed a couple of times so far, so I'm not going to do it again and again. Since you guys are already aware of all those things, so please do it once again. So this is the 20 news vectors. So here is the 20 news vectors. fs-ls. So this will have TF vectors, TF IDF vectors, dictionary, exactly similar to that of the previous execution. Okay. Then now the first thing I'll do is, since I have generated all the TF vectors, guys, please do remember that CVB algorithm does not use TF IDF vectors. It will not use TF IDF. It is good at using term frequency vectors only, since it has to identify the topics out of the documents. It will use TF vectors. Let's see how internally how it works. Okay, so guys, what this CVP or LDA algorithms does is, this actually creates the term vectors. Sorry. So this actually creates the term vectors. So those terms vectors will be something like the combination of multiple terms. For each document, it will create the term vectors, guys. So those term vectors will be something like, say, agriculture, and some weight associated with it. Okay, comma. Then there could be rains, some weight associated with it, and there could be some terms. So what could be possible terms in agriculture? Wheat. So this will actually create this word vector. So instead of term vectors, let me show you like this. So it will create word vectors like this: agriculture, rains, okay, wheat. So it will create this word vectors, rice, and then it might create different word vector like politics, say election, okay, results. So this will create this kind of word vectors. Okay, so this word vectors will be useful for identifying the topics, guys. So for creating this kind of word vectors, it purely leverages on TF vectors. TF vectors are nothing but term frequency vectors, right? So it uses the term frequency vectors, but it will not use the TF IDF, because TF IDF is the one when you are doing clustering. But here, since you are identifying the topics for the documents, it will use the word vectors. So in order to come up with this word vectors like this, it will use the term frequency vectors, guys, to come up with this word vector. So now the first step I'm going to do is, I'll actually generate this I'll run a command called as row ID command. This basically what it does is it will actually generate the index for each of the term frequency vectors. Okay, so that's why I'm passing the input as the TF vectors and the output as some CVB row ID input. This will create a couple of folders, and those folders will contain ID and okay, sorry, I have used writers vectors, it looks like, sorry. Okay, sorry, let me change this path to this one, continuous vectors. Okay, so continuous vectors output I'll say out, and here also I'll change it to continuous vectors. Okay, so now let me generate that. So this is like pre-processing step which we need to do in order to recognize which vector is coming from which ID and all that stuff. So if you open up that output and try to see what exactly this contains. Okay, so sorry. Hadoop fs-ls. This is the output. Sorry guys. This is the one. Okay. So this will have this document index and the matrix also both. Let us see what the document index contains. Hadoop fs-text and the document index. Pipe more. So this will have each document which is vector and the document and the index associated with the document. And then what else we have? We have this matrix also, right? So let me print the matrix and show you what exactly this matrix contains. So this will contain the actual vector, okay? Vector and this index of that vector. Okay, so this is the vector and the index. So this, in order to create that, we are running this row ID command. So it generates the ID for each of those rows in the sequence files. So now that we have generated this, so now let's run the CVB algorithm over that. So in order to run the CVB algorithm, so Mahout, let me just copy it over here. So Mahout CVB stands for collapsed variational base. Input path is this. I have to change this input path to have this input path. Continuous scripts out. Okay, so this is the input path from matrix I have to supply, and then the output path will be some output path, say 20 news vectors out, and then CVB output, and then the dictionary is going to be this. I have to change this also to have this. Sorry. I'm just changing the dictionary path also, since I'm not using that writer's dataset. So 20 news dictionary file, and then data type, which is CVB topics, and then empty. This is where the model will get stored, CVB topic model. So -k, which is number of topics, 10, and the -x, you can supply it as 20 over here, number of topics. -x is 10, which is number of iterations, and overwrite. So before I run this, I should actually delete the outputs from this paths. So in order to delete that, so let me Hadoop fs-ls/cvb star. Let me see what all the directories are there starting from CVB. So CVB topic model. So all these things I have to delete. Okay guys. So now that I have created some Mahout CVB-I. So if you want to see what is the usage of the CVB algorithm, Mahout CVB help. This will actually show the help assistance for the algorithm, guys. What all parameters you guys can use for this. So in this DT actually stands for what? DT stands for document topic output. So this is where each document and the topic output will get generated. And then MT stands for topic model temp directory. So this will be here the model will get generated over here. This model we can use for further classification of topics. Okay, so let us run the command now. Okay, so Mahout CVB, this is the input path where the matrix has got generated previously using row ID, and this is the output path where the actual output will get generated. Dictionary, this is the dictionary file. DT stands for CVB topics, doc topic over here, and MT model will get generated over here, and the remaining arguments.